In this tutorial, I'm going to be taking you through the nomenclature of organic compound, as you can see on the board. Yes, and on the left hand side, I write down some words 1 to 10, which are standing for the Greek numbering from 1 to 10. And this serve as the indicators of the number of carbon. So you have to be well acquainted with these names. Meth represents 1 carbon. Hept represents 2 carbon. Pro represents 3 carbon. And depending on the type of organic compound you are talking about, that is when you will know what we end it with. If it is alkanes, then if you pick meth, it's going to be methane, hept, ethane. And if it is alkenes, it will be methane, ethane. So these are the prefixes that are being used in naming organic compounds. But it is very essential that you know what they mean. So when you hear somebody, when we say nomenclature, we are simply talking about the structure of organic compounds. And it can be in 2 forms. It can either be from name to structure or from interpreting a structure and to provide the name. You can either be asked to provide the name of a structure or write the structure of a name. So you have to be very, very skillful when it comes to this. So these prefixes are very, very important, as I've said, and you should master them. All right. Let's say, for instance, you are given, let's start with name to structure. As you can see the arrow, the part B will be structure to name. So let's say you are given a chain and you are asked to draw the structure of a chain. You know that for every organic compound, there is what we call the prefix and there's what we call the suffixes. The prefix suggests the number of carbon, while the suffix suggests the group that organic compound belongs to. So the earth suggests carbon number of 2. You know, I said the prefixes are the indicators of numbers of carbon. So if you hear earth, it's actually telling you that this compound you are about to draw contains just 2 carbon. So the first thing you are going to do is to show the 2 carbon. You know, carbon is the foundation of all organic compounds. That's why you are going to draw the carbon atom first. And if you remember, carbon is in group 4. So hence, it likes to bond 4 bond. And because of that, anything we are doing, we must make sure it's bond 4 bond. And when it comes to hydrocarbons, these suffixes, ANE, is suggesting that this compound is an hydrocarbon and it is an alkane. Since it's an hydrocarbon, what you are expecting in your structure is just strictly carbon and hydrogen. So now, for you to complete the 4 bond for each of the carbon, that means the supplement you are going to attach to each of them is the hydrogen. So this structure is a structural formula, but it is called condensed structural formula. Condensed structural formula. So you can continue further to draw this structure in another way by showing all the bond using a dash line. So this type of structural formula is called a dash line structural formula. Dash line structural formula. All right. This is the structure of this compound. Now, there's another formula that is very, very, very essential, and that's what they will give you most times when they are asking you to draw a particular organic compound, and you should provide the structure. This is what we call molecular formula. In molecular formula will only show the number of elements present. Molecular formula, it will show the number of elements present. So it just counts 1, 2. That means in this compound there is 2 carbon, C2. And then how many hydrogen? 1, 2, 3, 4, 5, 6. That is C2H6. So it means for ethane, this is the structure. How it's going to be in condensed form. H3C, CH3. There's a reason why I did not write this H3 at the front. H3, if you are writing at the left, you must write it to the back. And if you are writing to the right, you must write it in the front to avoid the issue of rotations. So if you are writing to the left, let this H3 be at the back and let this H3 be in the front. So molecular formula is just showing the number of entities that are present. So it's not really showing how they are bonded. C2H6, just for us to know that in this organic compound, though, there is 2 carbon and there's 6 hydrogen. But on the other hand, structural formula, like category A and B, they are telling us how the atoms of hydrogen are distributed around the carbon atoms. And the difference between a condensed formula and a dash line is that condensed formula helps us to manage space and make it more smaller because it's only summarize all the entity around each other. But when it comes to dash line, there's no summary. Show how each element are bonded using a dash line. So owing to this structure, if you check the dash line structure, you will see that each of the hydrogen are bonded by a single bond to the carbon atom and the carbon to itself. So hence, each of the carbon is saturated 1, 2, 3, 4, showing that we are actually correct because we know that alkane is a saturated hydrocarbons where there is no single bond or double bond. I hope you are getting it. You can pause the video and try to attempt. Yes, we are still on interpreting a name into structure. So let's take the second example, 18. So let's say, for instance, we are asked to write 18. Et suggests that there are just 2 carbon, and in suggests to you that there will be a double bond in this organic compound. So therefore, it means it is an unsaturated organic compound. That means hydrogen is not enough. So the very best thing is that you are going to put the double bond at the first instance, knowing that out of the double bond, one is a sigma bond, while the other is a pi bond. The black one is a sigma bond, while the other is a pi bond. In every double bond, there is one sigma bond and one pi bond. In case you don't know the spelling, sigma bond and pi bond. So the one in black is the sigma, while the one in red is the pi. In every double bond, there is one sigma, one pi. So since you know that alkenes, we have double bond, and we are going to 4 for each of the carbon. So to balance the 2 structure and the 2 carbon, we have to introduce 2 2. That's the correct structural formula of 18. Now, let's now write the molecular formula. The molecular formula will just be, I said molecular formula just reveal to us the number of elements present. So just count 1 2. That's C2. And how many hydrogen in total? 2 plus 2, that's what? 4. That is the molecular formula of 18. So on the other hand, if we are asked to draw ethyne, et still suggests to us that there are 2 carbon. So you are going to write, since ethyne, ine means there is triple bond. So show the triple bond at first. There will be 2 pi bond added to the sigma bond. So to complete 4 for each of the carbon, we only need 1 1 hydrogen. When we write this 1 1 hydrogen, so this is how the structural formula will look like. Sorry, molecular formula. Molecular formula will just show you the number of elements present. 1 2 C2, 1 2 H2. That is why the structural formula for 18 is in the condensed format is H2C CH2. While for ethyne is HCCH. But if it is a molecular formula, the MF is going to be C2H4 for 18 and C2H2 for ethyne. The same way you are going to do for other ones too. Propane, propane, propine. Just know that the pro suggests 3 carbon. While the last name, if it is ane, know that there is no double bond. If it is in, there is 1 double bond or more. If it is ine, there is triple bond. Just know that, and then you are good to go. This one is somewhat simpler. I'm going to take some of the complex naming now. I told you that there is what we call the condensed formula. So this is the condensed structural formula of a compound, and we are asked to transform it from the structure to the name. So this is one of the most very crucial aspects you have to know. The one we did earlier is actually simple. That one is just an introduction so that you can understand what it means. So now we are doing a structure, and we have to write it. We have to write out the name. Very simple. So whenever you see a structure like this, don't be scared by the mysterious look. So don't be scared at all. Just try to check carefully, observe, follow the principle, then you will get the answer. So very simple. Whenever you see 3CH3 surrounding a carbon, so your emphasis should be on this carbon. So it's because this CH3 are surrounding a single carbon. So the first thing you are going to do is to write a letter C and let this CH3 surround this carbon. So this carbon is the one I put here. Then this CH3 is 3 bar. So let them surround this carbon. So that will now be like this. So that means I've already covered for this and for the 3 of them. So I'm here now. So that means there's a CH2 after them. So that CH2 means apart from the carbon, 2 hydrogen are attached to it. So show it through the dash line. This one is condensed formula, condensed. While the one I'm drawing below, this one is what we call the dash line. Dash line will reveal what actually is happening. So I've done the CH2, so I'm here now. So I'm here, CH. So to draw the CH, it means I have to put 1 hydrogen here. And then for this one, it means I have to put 2 hydrogen here. All right. Sorry, the structural formula, I have to correct something here. This is actually what the questions tell us. This one's supposed to be, yes. Please, sorry. The CH is 3 at that middle. So if you don't see this one is CH, that means I'm here. This CH here, I'm here. Then I'm here now. Another CH. You see? So that means I've captured this one, this one, this one. CH. Then the last one is what? CH2. That means I have to show a CH2. One attaching here, one attaching here. Now, before you can name this organic compound, you have to check, are all the carbons satisfied? Each carbon must have 4 4. So if we count for here, 1 2 3 4 satisfied. For this one, 1 2 3 4 satisfied. 1 2 3. You notice that this one is not satisfied. Check the other carbon that is next to it. 1 2 3. So both are not satisfied. To satisfy them, that means you have to put an extra bond, double bond. So you can now check again. 1, 2, 3, 4. That's satisfied. 1, 2, 3, 4. That's what? Satisfied. Now, if you now check this one again, you will see that this one is 1, 2, 3. It's not up to 4. Carbon must be 4 before they are satisfied. This one too, 1, 2, 3. I mean, these people too are not satisfied. So you are going to put another extra bond. So that is now making it satisfied. This is now 1, 2, 3, 4. 1, 2, 3, 4. So when all of them is satisfied, then you can go ahead to name the compound. But this is it. Now, for this compound to have double bond, it means it is an alkenes, E-N-E. Alkene. It is an alkene. Alkene compound. It's an example of saturated, it's an example of unsaturated hydrocarbons that have double bonds. But you see that how many double bonds are you seeing here? That's 2. So this is a diene. A diene is an alkene compound that has more than one, that has 2 double bonds. That has more than 1 double bond. So the double bond is 2, therefore it is a diene. So because it is a diene, how do you name a compound like this? Don't forget that this diene also has attachment. So on the normal ground, you have to check from both sides while naming, and you have to check for your longest chain. So the first thing we are going to check for is in different dimensions, where can we get the longest chain of carbon? So if I start counting from here, this 1, 2, 3, 4, 5, 6, 7. Now let's check. Is there any orientation where I can have more than 7? 1, 2, 3, 4, 5, 6, 7. If you come down, if you start from here again and go up, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So apart from 7, no other chain is more than 7. And thank God our straight chain is part of this 7, the longest chain. So just use the straight chain as your longest chain, since it's also 7. We can also use this one to 1, 2, 3, 4, 5, 6, 7. But since the straight chain luckily fall to the longest chain, then we can use our straight chain. Now, how do you name this compound? Now, because it's having 2 double bond and it's having attachment, when it comes to naming, you give priority to the double bond. So any side that the double bond fall mostly to is the side you are going to name from. If you name from this side, although there are attachments here, but the double bond is far from this region. That means if you come from here, 1, 2, 3, 4. So it's too far at this region. The double bond is far from this region. But if you come from here, immediately when you count one step, 1, you will see the double bond. So it's not that far. So you are going to consider coming from the right, not from the left. All right. So that's why you have to always check your both sides. After you pick your straight chain that you want to use in naming, your longest chain, make sure you check from both sides. Any side that the double bond is not close to, you are going to what? To neglect it and go for the other side. I will have considered this place if there are no double bond there because of this attachment. Because the attachment is closer to this side compared to this side. But whenever you have attachment and you have double bond, you give priority to double bond than the attachment. So here, I'm considering the attachment, and the attachments are more closer to this right hand side than the left hand side. Therefore, if I'm naming, I'm going to say 1. So this carbon is carbon 1. So you can name it as carbon 1. So you can name them as carbon 1, 2, 3, 4, 5, 6, 7. So instead of naming it from here, 1, 2, so name from here because of the double bond that are closer to this region. So now you now check very well. 1, there is a double bond as carbon number 1. If you come again, this carbon number 2. If you go again, carbon number 3, that means there's a double bond as carbon number 1 and 3. So the first thing you are going to start with is the longest chain. 1, 2, 3, 4, 5, 6, 7. This 7 is suggesting what? Hept. You are going to say hept. Hept. Now you are not going to show the position of, but before you do that, you are supposed to talk about the attachment. Sorry, I omit that. The attachment. So the attachment now, since this is like this, just say 1, 2, 3, 4, 5, 6. So the carbon that has the methyl is carbon number 6, and it's having how many ethyl? It's having 2 methyl attached to it. 1, 2. You know methyl are attachments. You now say 6, 6 dimethyl. That's the first thing. So you have shown us that there is 2 attachments and it's on 6, 6. If you have labeled from here, not minding the double bond, this carbon will have been 1, 2. It now be 2, 2. That's wrong because you have to respect the double bond. While respecting the double bond, our supposed 2, 2 has now become 6, 6, and that's the most correct naming. 6, 6 dimethyl. That will now be the next thing you are going to do is now to write the name of the compound. Notice you will know that to separate number and number, I'm putting what? I'm putting a comma. But to separate a number from a letter, what am I putting? An hyphen. It's very, 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 very important. But if you are separating 2 letters, don't separate them, just leave them like that. Write them together. All right, it's allowed. Number and number separated by a comma. number and letter separated by an hyphen. This is 6,6-dimethyl Hept. So you cannot conclude yet. Hept is just what you need for now, because Hept is suggesting that there are 7 carbon on a straight chain. 1, 2, 3, 4, 5, 6, 7. So Hept. Now what you will end it with depends on the other factors that are present in this chain. So you now check. There's a double bond at carbon 1, 1, 2, 3. That means there's double bond at carbon 1 and 3. So it's going to be C6-dimethyl Hept hyphen before a 1, 1, 3. This 1, 3 is just to show where the double bond is. You're not going to say 1, 3, then diene. It's diene because there are 2 double bonds. So this one is telling us about this one. This 3 is telling us about this one. But between number and number, a comma, between number and the next letter is going to be what? Diene. The answer will now be 6,6-dimethyl Hept 1, 3 diene. That's how to name that structure. It's not hard. In fact, if you see other questions like this, that's how you are going to interpret it. If you find a double bond and you have an attachment, consider the side that the double bond is more closer to, and then that's how you name. Are you with me?